And welcome back to another LeetCode video. Today we're looking at LeetCode problem number 5, longest palindromic substring, which is a classic problem on LeetCode that you need to be able to solve. I'm going to show you how to solve it with a two-pointer approach today, which is as efficient as a dynamic programming approach. So let's see what we're dealing with here. Well, we're given a string S and we should return the longest palindromic substring in S. So that means we're going to scan through S and look for any palindromes that be in S. And we should remember the largest one. Or if there are multiple largest ones, return any of them. So here in this example, we have the string BAD, and obviously the palindromic every character is a palindromic substring of length 1. We don't have any palindromes of length 2 in here, because that would require consecutive characters like an x2. But we have two palindromes inside of S of length 3. So one is BAB and the other one is ABA. Right. So how do we detect these palindromic substrings? Well, a naive approach might be, let's just iterate over all of the indices, over all of the characters in our input string, and see if we can expand from the initial character to a palindrome. And then we continue expanding our little palindrome for as long as we can until we run into a mismatch between the right and the left character. So here, if we started at index 1, where the A is a palindromic substring. So now we're trying to expand A to BAB, and it's also palindrome. So nice. Now we found one of length 3. We have to remember that one, but then we can't go beyond that because we reach the end of the string and so forth. So yeah, what I just told you is exactly the approach that we're going to use. And it should be clear that this is going to be a quadratic approach in the number of elements or in the number of characters that we have in the string. So we can already write that down, O of n times n time. And that is simply because in the worst case, all of the characters in the string are equal. They're all maybe A's, for example. We still have to iterate over all of them. And then every time we try to check whether there's a palindromic substring here of maximum length expanding from that character, we also have to iterate at most n characters, because we can expand the palindrome until we reach the limits of the string S. And in terms of space complexity, well, we need to return a palindromic substring, and the same worst case example can be used here. If the string consists of only one letter, but n times, then our result will be exactly that string, which is also of length n. O of n base, right? So, well, let's first start with our little loop. So, as always, we need to define like a result variable that we're going to return at the end. That'll be our longest palindromic substring. And then, like I said, we're going to iterate over all of the elements or all of the characters in our string S, and we're going to check, well, what is the longest palindrome that we can start from S, right? So we start at I. What is the longest palindrome? Well, that takes care of all the odd length palindromes where we have a single character as the center of palindromic substring, but we can also have the case where we have two characters in the center of the palindrome. So we have to take care of two cases, where the left is equal to I and right is equal to I plus 1. And the other case is where a left I and right is also I. By that I mean the initial left and right pointer of our palindromic substring. Then we're going to subsequently try to decrease the left pointer and increase the right pointer until the substring between left and right is no longer a palindrome. So that's what we're going to implement in a little helper method. Get from left and right pointers. We're going to feed it a left one and a right pointer. Now what we're going to do is, well, we have a little result here as well. And initially it's just going to contain the pointer to the left pointers. And at the end we're going to return this. Here. Now we add a loop for our expansion. While left is larger or equal to 0, right? And right is smaller than the length string. Only then we can compare characters at the left, and we want to check whether they are not equal. So if they're not equal, well, we're done. So we can just break out of the loop. However, if they are equal, it means we can decrement left to expand the substring and increase the same. In the end, we're just going to return our result. Now, we have to update our result actually. Yeah? So if we checked that left and right characters are the same, we have to update our left and result. Because at some point, they will not be equal, and then it's no good to return the current left and right pointer. Instead, we want to return the ones that we had for character at position to character at position right anymore. Now, down here in our little loop, we're going to get the left and the right pointers to the maximum palindromic substring that starts at position I and I. So this is for the odd length palindromes, where we only have one character in the middle. And the other one is where we start with palindrome center is at I and I1. Right, so that is all fine and good. Well, how do we update our result variable? Well, we have to calculate. So what we do is we say if the length of our result variable is smaller than, now we have to measure how long is this max palindrome, and we do that simply by math +1. In that case, we're going to update our result variable, and left, right, 1, since the end of the range is not included. We do the same here. So that is everything, I believe. I don't know if that's better to read, but that is everything we really need. Get max palindrome left right is an O of n operation. Here we have another O of n over the characters of the string, and combined that gives us an O of n. So let's run this. All the tests pass, and they do for both of our cases. And now we're going to submit it. Should get accepted. Right, there you go. So yeah, that concludes this how-to video, and I encourage you to try this implementation and not just the dynamic programming.